everyone, welcome to the Big Data Show. Today we are going to discuss one of the most important concept in Apache Kafka. And this key concept is topic. As a data engineer, when you start writing your big data pipeline which involve Apache Kafka, the most important thing that you will focus most is the topic. So firstly, let's try understanding what is a topic. If you have never heard about topic in Apache Kafka, just imagine that it is just like a table of transactional databases like MySQL, Oracle, MySQL Server, right? But it is without any constraint. Before going deeper into the Apache Kafka topic, let's try to understand how does Kafka actually stores the data. And before moving forward, let me tell you a very good story. Many data engineers believe that MapReduce is slow with compared to Apache Spark because MapReduce involved disk I/O, whereas Spark is faster because it does everything in memory. And because of that, many have this misconception that every distributed framework or platforms will be only faster if they operate in disk. But this is not true, my friend. Apache Kafka still stores the data on disk in form of files. And this is the common misconception that access from disk is actually very, very slow. This is not true. Access from disk totally depend upon the pattern in which you are accessing the data from the disk. There are actually mainly two patterns of seeking the data from the disk. One is random access, another one is sequential access. Okay, let me just firstly make you understand that what is a random access and why this is actually slow. In random access, what will happen that in disk access patterns, if you are seeking the data from the disk, then the arm has to move here and there. For example, if I'm here right now and I have to seek some data which is actually here, then I have to move my arm from here to here. For example, if I'm here and I have to move to this particular data, then I have to seek the data from here to here. So same way. So in this random access patterns, the lot of movement is there. But if we go by the sequential access patterns of the disk, then data will be always written or read from sequentially, like from here to here, from here to here, from here to here. And it will be always very, very fast. So I hope you understood now that even though Kafka uses disk, but it uses sequential access patterns to fetch the data from the disk. And that's why Kafka is fast. Well and good. Now let's let's try understanding that how does Kafka take the advantage of sequential disk access pattern. So Kafka takes advantage of sequential access pattern by an append-only log. What does that mean? This means that on disk, where in Kafka, the data will be always written in form of sequential and always read in form of sequential. Like the first data or first event will come here. The next event will come here. The next event will come here. And next event will come here. Like if you have seen the logs, if you have seen the log in, or if you have used log4j of Java, then you have seen that the logs are written like that. I am Ankur. I am a data engineer. Log 1, log 2. So this is append-only log. The log will be always appended in the end of the files, right? You cannot insert some log in between that, right? So same thing happen in Kafka. it will be always append-only log. Like whenever new data will come, if you want to write, it will be always written in the end of the files. Same thing in Kafka, you can always read the data sequentially. Like you can always move to one position, then you can do the forward scans. But you cannot hop here and there. Well and good. Perfect. So I have written that Kafka uses append-only log at its primary data structure, and append-only logs add new data to the end of file. Okay, and this access pattern is sequential. So technically speaking, a topic is a log of event. So if we want to visualize it, then how we will visualize the log of event? Like this is a log, and here multiple events will be there. This can be called E1, E2, E3, E4. In our previous video, we have understood what is an event. Sometimes in a layman terms, it is also called messages, right? So what is an event? Event is something which happened in the past, right? So this Kafka topic is actually log of the event. And if you say in a loose manner, then you can say it is a logical challenge where producer will write the data and consumer will read the data. Well and good. Okay, but sometimes I've also listened to the people who termed Kafka topic as a queue. I don't agree with that, because when we used to read computer science in our graduations, then how do we consider queue? Queue is a data structure which will be always FIFO, first in, first out, right? So if this is a queue, and if we keep pushing the data, it will be lost when someone reads it, right? But this does not happen in Apache Kafka. Like in queue, the first data will come, then it will be here. Once the new data will come, then this data will be pushed to here, and new data will be coming here. Well and good. Again new data will come, then the next new data will be coming here. And after some times, this will keep on pushing, and this data will be read and it will be thrown out from the queue. Right? That is the basic data structure of the queue. That's why I call this as a log of event, not just a queue. And in Apache Kafka, actually you can retain the data for some period of time, and that retention period and retention size is actually configurable. Like when producer will write the data to the log of event, which is nothing but a Kafka topic, and when some consumer will read the data by subscribing to that topic, data will not be lost from that particular topic. And this is the reason why Kafka captured a lot of data engineering work, a lot of data engineering domain, other than the traditional messaging queue. Here, even after one consumer consuming the data, it is not lost. The data is durable. It is stored on the disk. We can store this data for 3 days, for 5 days, for 3 hours, for 7 days, for 1 year, even infinity. But practically, as Kafka is very, very expensive systems, practically in most of the data engineering pipeline, where you will use Kafka to store your data, you will store the data for some duration of time, like for 3 days, for 7 days, for 3 hours. Well and good. So we should not call this as a normal queue. We should call Kafka topic as log of event. Perfect. I hope you have understood. And how these logs are arranged? These are always in append. There will be one log, and after that another log will come, 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 another log will come. It will not be any random fashions, because we have seen that Kafka uses the sequential disk access patterns, and which makes them very, very faster. And we will understand that why Kafka actually uses sequentials. Perfect. Now, I've already make you understood. Now, let's try to understand these things. Whenever you will try to read from Apache Kafka topic, which is nothing but a log of event, you will always read by seeking, either by the first offset, first log of the log, and then you will forward scan it. Like you will read this data, Then you will start reading all this data. Or you can seek to any arbitrary offset like this particular thing. You will seek, you will keep your arm here, and then you will start forward scanning it. You cannot read this and after that this. You cannot read this and after that this. No, you will always go to some arbitrary offset or the initial offset, and then you will start forward scans. So this is the second characteristics of Kafka topic which I've written here. Can only seek by offset arbitrarily and then forward scan it sequentially. Well and good. I hope theory is making sense to you. For now, we have understood that Apache Kafka topic is nothing but a log of event, right? Then we have understood these logs are always in append mode. One cannot overwrite it, okay? Then we have understood that if you want to read the data or even write the data, you cannot write it randomly because Kafka uses sequential disk access patterns, so it will always read it sequentially. You can surely move to one point and then you can move sequentially, but that will be in the forward scans. Well and good. Perfect. So the third characteristics which I've already explained when I was explaining just before sometimes, that event in Kafka or logs of event is immutable. Practically speaking, it is impossible to change. Once, if you have written some event in your Kafka topic, it can't be changed. And this makes Kafka a very strong system, which is very much reliable. If you write something, you cannot overwrite it. You have to either read it, okay, or complete your process, or you can skip it. Well and good. Or you can even delete it. But you cannot, these are immutable. You cannot change that. Well and good. So, okay. So let's recap whatever we have learned till now about Kafka topic. So topic in Kafka is nothing but log of events, right? I hope you will remember this diagram. The second characteristics that they are append-only. Well and good. Event in Kafka can be stored for some duration of time. Like when producer will write the data to the Kafka topic, and when some consumer will read the data will not be lost. After some duration of time, another consumer can come and they can keep reading it. Then again, some other consumer can come and they can subscribe to the topic and they can again read it. So this is the benefit. Like you can keep your data in Kafka topic for some duration of time. Actually, even for infinite number of amount of time, right? So this data is durable. This is the third characteristics. And the fourth thing, that event in Kafka is actually immutable. You cannot change it once you have written it. I hope you have kept these four things in your mind, these all characteristics. And let's try understanding Kafka topic by very simple layman example which I have created from my boarding school from my childhood. But before moving it, let me just read one line. The simplicity of log and immutability of the content in Kafka are key to its success. For now, just read this line. I will make you understand. Cool. Let's try to understand now what is Kafka topic in a very layman terms. And I will give you an example from my childhood. So I used to study in a army school which was running in a boarding school fashion. Well and good. So for reading newspaper, we have to go to library, and then before reading the newspaper, we were actually subscribing that I will be reading Times of India. I will be reading The Hindu. These are all newspaper which is very much used in a Indian market. Okay. So for me, my librarian becomes the producer who is producing the data. That newspaper will be called as topic. And I, being the consumer of that news from my newspapers, I will go and consume my data. I will subscribe to Times of India and go and read the data. But this does not mean that if my some other friends will go after some point of time, or if they will go parallelly with me, they will not able to read Times of India which is there in the library. So in library, this newspaper will be preserved for some point of time, like 3 days, 7 days, or even 1 month or 1 year. And after some time, librarian will replace it or remove that newspapers. So if you consider, this is a classic example of Kafka topic. So here newspaper is a Kafka topic. Your news librarian will become a producer and you will become a consumer. Okay. And I'm focusing this again and again. Data will not be lost, like newspaper will not be lost just by you, like by reading after completing your reading. With you, your friends can go parallelly and they can even read it. Well, so I've just written these things. I will be sharing these notes in my descriptions. You can read these notes after completing of the video. That will make more sense. So I've written everything line by line. Perfect. I make you understood this particular things. I hope now you have clear that what is Kafka topic. It is nothing but a log of event. But let's go practically and let's try to understand that what is there in Kafka topics. So Kafka topics is actually divided into multiple partitions, and this is called partitions in Apache Kafka. So you might have heard that Apache Kafka is a distributed platform, right? And every distributed platforms believe on scaling horizontally. Like they will not keep adding the machines and then they will scale. No, they will always keep some machines at one, keep one software at one machine and another piece of software at other machines. And if needed, they can always add more machines. So in this way, they scales, right? It happens even with the Apache Spark. The same thing, Kafka topics is divided into multiple partitions. So, for example, this is your Kafka topic, which is nothing but a log of event. It will be divided into multiple partitions, and these all partitions can be present on different machines of Kafka clusters. Like it can be scaled horizontally. If you needed more partitions, then please add more machines, and then you can have multiple machines working together. So if you take this example, so this is the topic, right? This is the topic. Let's suppose this is divided into partitions, 3 partitions. Partition 0, so partition 1 and 2. So I'm starting my counting from 0. And it is divided into 3 partitions. And what is this partitions? This partition is nothing but ordered sequence of event. Like a partition 0 will always start, the first thing will always start from 0. And this order sequence 0, 1, 2, 3, 4 is actually called offset. This 1 will be called offset. This 2 will be called offset. And what is a partition? Partition is a nothing but an order sequence of the event. And what is a topic? It is a log of event. And this log of event is divided into multiple parts. It is not stored in a single machine. Well and good. So let me help you to understand. Whenever somebody will try reading from Apache Kafka, like using a Spark, a structure streaming, Apache Flink, Kafka Connect, or any other things, or even by Spring Boot, they can either read from the earliest. So if they pass the earliest, they will read from the first offset present in one partition. Like they will start in partition 0 from offset number 0. Offset number 0. For 1, it will start from 0. And from 2, it will also start from 0. But they can also define some arbitrary number. Like they can define that in partition 0, let's start reading from 3. Okay, let me write it here. So from partition 3, partition 0, let me start reading by 3. For partition 1, let me start reading by 20. And for partition 3, let me start reading by 5. We can do that. We can always go to partition this particular positions. And for 1, we will go, let's suppose this is the 20. So we can always go here. And let's suppose this is 5. And if this is a 5, so we can always go there. But after that, we will be always forward scanning it. Like after this, we will be always reading 4, 5, 6, 7. And from here, 21, 22, 23, and 25. From see here, 5, 6, 7, 8, 9. So I hope you are able to get it. Like this was the reason why Kafka actually implemented their disk access patterns in a sequential fashion. Because most of their consumer applications we're always designed to read the data in a sequential way. And this also makes Kafka a very, very fast system because arms on the disk don't have to move here and there, here and there. They will always be moving in sequentially here, 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 and then here. Well and good. So I've also written some theory. So partitioning take the single topic log, break it into a multiple logs, which can live on the separate node in a Kafka cluster. And this is the property, and this is the reasons why Kafka is scalable. This helps Kafka to scale horizontally. Well and good. Okay. And then I have told you what is a partition. So partition is like partition is an ordered sequence of event. Okay. And each partitions within each message within a partitions get an incremental ID, which is called as offset. So this is the offset, right? This is the offset. Sorry. This is the offset. This all numbers are called offset. I hope you are getting, and you are getting what is partitions. But now let's try to understand the main question, that how does the event are distributed across different partitions of topic. This is the very much asked questions in a data engineering interview, and you have to actually understand it. So there are two scenarios actually. Let's suppose if the keys are null and if the key has some value. Before understanding, let's revise it. How does data is stored in the Apache Kafka? Actually, data is stored in the form of bytes on the disk. But you can serialize the data, and your data will look something like this, right? There will be some key and there will be some value. And this is your one of the event. This is your one of the event. This is another event. Like let's call this as E1. Let's call this as a E2. And this will be your another event. Let's call this as a E3. So there can be like dividing the events into multiple partitions actually depends on two things. Like if your keys are nulls, it will be always distributed using round robin. Like the first message will go to this, then it will go to this, then it will go to this, then this, then this, then this, then this, then this, then this. This is always in a round robin fashions, and this is not actually recommended. You should always pass some UUID and some unique value to your event of the keys, because that is the identifier for your message. And let me help you to understand. In Kafka, if let's suppose if you are having some key, let's suppose for this particular event, I am having one key 1. For this key, I am having key 2. And this key, I am having key 3. So Kafka will come up with some hash functions. Okay. So let's suppose, just for simplicity, let's define the hash functions, which is nothing but let's define by our modulo functions. Like, so if 1 is modulo by 3, then what will come? 1. If 2 is modulo by 3, then what will come? 2. If 3 is modulo by 3, then what will come? 0. Right? So Kafka will use these hash functions and take this key and will keep the partition number 3. So partition number 1 to the first partition. So first event in the first partition. Like this is my first event, right? So it will go to this particular partition. Then this second partition, so second event will go to this second event will go to this partition. Then the third event will go to this partition. The same way, if some same type of value will come, then the modulo will give the same result. Then this will go to this particular partitions. So let's suppose you are having a customer ID, okay, and you want to send the data of customer in your Kafka topics. Then for the same customer ID, it will always go to same partition, because you will apply modulo functions, you will apply some hash functions, right? And that hash functions will actually create the same value of that customer ID. So you can always guarantee that order is always maintained in one partition of the topic. Order is not maintained globally. Like you cannot maintain the order in every partitions, but you can always maintain the order in one partition, right? So because if customer ID, that particular customer ID is put 334, if you apply the hash function, if for the first time, if the hash function is giving partition ID 0, even if the new data for that particular customer ID 334 will come, it will again go to partition ID 0. I hope you are getting this. So you can always maintain the order in the same partitions of Kafka topic, but global order is not possible in Kafka. And I hope now you understood why I have called partition as partition is nothing but an ordered sequence of event, and topic is nothing but a log of event. And what is an offset? Offset is nothing but a number which is given to the partitions of for each messages. So this is the one event, this is another event, this is another event, this is another event, this is another event. The same way for this particular partitions, this is another event, this is another offset, this is another offset, this is another offset. I hope you are understood it. You have understood what is the topic, what is a partitions, and what is a offset. And I hope you have also understood the characteristics of that. Like you have understood that logs in Kafka topics is immutable. They are always append only. And you have seen the benefit of using sequential disk access pattern. Like why it is sequential? Because you can see it is divided into multiple partitions, and every partition is actually following the order sequence, right? Then you have also understood in your Kafka, it's not like a traditional queue or traditional messaging queue where data is lost once if one consumer read the data. No, you can actually store the data for some duration of time, and that gives the Kafka the major benefit above other traditional messaging queue. And that's why it is used a lot in data engineering world. And I hope you are now clear about what is topic, what is partition, and what is offset. Let's meet in the next video and let's try going deeper in some more concepts. Like we will try to do some use cases. We'll also understand what is producer, consumer group, zookeeper, and many more things. Until then, if you like this video, please like, comment, and subscribe. And please leave your questions in the comment sections. In our free time, we will be always trying to reply to that. Until then, bye bye, take care, and keep learning. Thank you.